Hello, GED students. If you're joining me, I understand why. The directions here are weird. I get it. We've never seen anything like this before. However, this is a skill you need. To be able to distinguish between a linear and quadratic equation is important because we use different methods to solve them. So it says determine if the equation is linear or quadratic, then solve with the appropriate method. What am I talking about? Even the linear and quadratic equations, appropriate methods? Well, we've learned when we've been solving that when we're doing linear equations, that's when we use Kate's 3 wisdom principles. But when you do quadratic equations, which we did back when we did formulas, I had said to you that if you tried to use our linear principles where you work to get the letter alone, you could work and work and work all day, and you would struggle to get the letter alone unless you had some additional knowledge. All right. So there are multiple ways to solve quadratic equations. You're going to learn all of them in college, graphing and completing the square and factoring, and also what we're going to do today, which is just the formula from the formula sheet, because that's the way we tackled it in this unit. So we have what's known as the quadratic formula. Okay. But we don't know which one to use unless we can tell the difference. And really the difference is if you have a power on the variable. Okay. So if the variable has no power on it, no exponent on it, it's just a plain old x or a plain old y, we're looking at a linear equation. Whereas if you see the variable being squared, it's a quadratic, and we really should use quadratic methods. Now we've learned kind of a shortcut to get around it in some simple cases, but these are not those simple cases. So let's take a look. First one says x squared minus 8x plus 15 equals 0. You might say to me, Kate, we have a plain old x and an x square. It's both the quadratic and a linear. No. It's whichever one's higher that I care about. So I do have an x squared term, so this sucker's a quadratic. In this case, it is an appropriate time to bust out that funky quadratic formula. Are you ready? Hit up your formula sheet. Don't cry. It's really not as bad as it looks. But it does say x is equal to negative b plus or minus, breathe, the square root of b squared minus 4ac all over 2a. So obviously to find this x, I need to know what this a, this b, and this c are. Well, the a, the b, and the c are the coefficients, the numbers out front of the x squared term, the x term, and the constant term, if and only if this sucker is equal to 0. So we can see it's equal to 0, check. That means we can see our A, our B, and our C. So A is the number out front of x squared. And you might say to me, Kate, there is no number out front of x squared. It's 0. No, it's not. Right? What's our invisible coefficient? If I don't see a number in front of x squareds, how many x squareds do I have? I just have 1. So my A is 1. Then my B, careful, it's not 8. Take the sign with it. It's negative 8. And my C here is positive 15, so just 15. And now I have the information I need to plug into my quadratic formula. So x is equal to negative b. Now careful, b is already negative 8, right? So basically when I say negative b, I want the opposite of b. The opposite of negative 8 is positive 8. And so I get positive 8. Plus or minus square root. Now careful, we learned when you square negatives, right? I need b squared. You have to use parentheses. So put your negative 8 in parentheses and square that. Minus 4 times a, which was just 1, and c, which was times 15. Keep that square root symbol all the way over all that. And that is all over 2a. Look at how my fraction bar stretches from the very first number to the very last. Ooh, but I'm not supposed to write an A. I know my A value. What was it? Oh, it's just 1. Cool. Now this thing looks ugly to simplify, but it's not too bad. I think what I will start with is just this square root portion. I kind of like to simplify around the plus minus symbols since my calculator doesn't have a plus minus symbol. So I'm going to type that entire piece into my calculator. So x is equal to positive 8 plus or minus, and let's type that entire piece in, the square root of, open up parentheses, even in your calculator, you need those parentheses. Negative 8, close the parentheses, square it, minus, use minus, not negative, 4, open up a parentheses, 1, close, open, 15, close. And that whole funky thing comes to 2. And simplifying the bottom of my fraction, 2 times 1 is 2. Great. Now that I've simplified everything around the plus minus, now's the time to deal with the fact that this is a plus minus. And what does that mean to us? It just means that there's 2 answers. There's one if you add and one if you subtract. So let's break it up. So I could add 8 plus 2 divided by 2, and I'll get one of the answers to the quadratic. Or I subtract 8 minus 2 divided by 2, and I get the other answer. So 8 plus 2 is 10, and if I divide that by 2, I just get 5. And 8 minus 2 is, oh, it's not 4. Woo! 8 minus 2 is 6, and if I divide that by 2, I just get 3. So 2 possible answers to this sucker. X is 5 and X is 3. So let's see, A, B, C, D. Here we go. This notation here is called set notation. Think of it like a bag of numbers. I'm saying there's more than one solution, and those solutions are 3 and 5. Now, if you're a ninja who knew how to factor x squared minus 8x plus 15 equals 0, you learned factoring at some other point since I haven't taught it to you in this particular unit, then good for you. You know the fast way to go. We kind of just went the long, slow way up the mountain to solve a quadratic. But I like this method because it always works, right? Not everything, you can't use factoring for everything. So even though it's a fast way, it doesn't always work. So I like a way that always works, especially when we're just starting out with this concept. All right, so answers 3, 5. Let's check out B. 5y plus y minus 32 equals 0. Now, what I'd like to say to you is don't be fooled by the fact that this thing is equal to 0 or by the fact that we see 3 terms here. None of those terms is a y squared term, right? I have 5 regular y's plus another regular y. We don't see exponents happen when we're adding and subtracting. This sucker is not quadratic. And if you can't see that, let's go ahead and simplify it so we can see it further, because we know that 5y and y are like terms. We can combine them. And of course, if I have a 5y and I add in another y, I will have 6y's. So I have 6y minus 32 equals 0. And now maybe it's easier to see that this is just a linear. It's not a quadratic. Another big clue I have, guys, is just the fact that there's only one answer each. Do you see that? Linears only have one answer, where quadratics tend to have 2 answers. So that's another big clue. But anyway, since it's a linear, I can just use my lovely 3 wisdom principles. And it's going to be super nice because I simplified already. Wisdom principle 1, done. I only have a letter on one side, so I don't even need wisdom principle 2. So I can just work now to get this letter alone. So let's do it. Let's move anything adding or subtracting first. I'll do that to both sides. New equivalent equation. Let's see, subtracting 32 and adding 32 cancel. 6y is what I have on the left. And of course, nothing plus 32 is just 32. And let's divide away that 6. Divide away that 6. Multiplying by 6 and dividing by 6 are opposites. They cancel. Y is alone, just like I wanted. And 32 divided by 6, it doesn't divide perfectly. And you can see here that A, B, C, and D are all in fraction form. So I don't want to divide through and get a decimal. I want to divide through and get a fraction. So I already have a fraction, but obviously it doesn't match these. And that's because it's not reduced. So you can reduce by hand by pulling out any common factors. It looks like 32 and 6 have a 2 in common. So you could just divide that by hand. And divide 32 by 2 and 6 by 2. let's see, 6 by 2 is the easier one. That's 3, huh? And 32 by 2, I'm going to use sight division again. 2 goes into 3 once, remainder 1, and 2 goes into 12 16 times. So y equals 16/3. But FYI, you can also reduce in your calculator, guys. If you just use the N over D button instead of the regular divide by button, type 32 on the top and type 6 on the bottom, then press enter. Your calculator will automatically reduce that to 16/3, and you can focus on the algebra instead of the fraction skills. All right, so y is equal to 16/3, so it's A again. All answers here are A. Final example, 25 is equal to 1/3 times 3.14 times 2.2 squared times h. Okay, good question. Is this linear or is this quadratic? Well, we've seen a lot of stuff like this in geometry where it didn't really matter if it was linear or quadratic because in geometry there's only ever one answer. The positive answer, we don't need the negative answer. So it didn't really apply to us, but still, I still want to run this test on it, whether it was linear or quadratic. And this is what I want you to notice. Yeah, there's a square, but don't let that throw you. It's not just about if a square appears anywhere. It's about if your variable is squared. In this case, my h has no square on it, right? That square over there belonged to the 2.2. So even though this might look like a quadratic, it's not. It's really just a linear. I'm going to use my lovely 3 wisdom principles and not worry about the fact that it has multiple answers. All right, so let's see here. First step is to do any simplifying I can do. And the really nice thing is, as ugly as this is, it's just a bunch of numbers multiplying. 1/3 times 3.14 times 2.2 squared times h. When you look at it that way, it's just like I have 4 numbers multiplying. And even though I can't multiply h in, I could multiply together the other 3 numbers because they're all just numbers. So let's do it. So I'll do 1/3, arrow out of the fraction, times 3.14 times 2.2. I won't forget my square, and I get a nasty number, but that's okay. So I'm going to have the equation 25 is equal to my nasty number, yada, yada, yada. I'll keep the whole number in my calculator, but I'm not writing it all down, times h. And yeah, I'm keeping the whole number in my calculator. I'm not rounding yet. Let's see. Now I need to solve. And that ugly number and h are just multiplying together, so I'll divide away that ugly number. And I can do whatever I want as long as I do it to both sides. Now, multiplying by that ugly number and dividing by that ugly number are opposites. They cancel. H is alone just like I wanted. And 25 divided by that particular brand of nastiness, I arrowed up to get my nastiness, is 4.934, yada, yada, yada. Well, there's no rounding directions, but I sure can see my answers are rounded here. So what am I closest to? I'm closest to 4.9. Hey, all answers are not A. That one's D. If I would have been planning better, I could have had ADD, which I already have, but I could have had it in my word problem too. All right, you guys. Strong work. Proud of you. Happy learning.